Let's talk about something that's really tricky. How in the world do you explain something you can't actually see? It's a huge challenge, especially in science. Today we're going to dig into a really cool way of thinking about this, an approach that helps make the invisible, well, visible. I mean, really think about that question. For a kid, concepts like gravity or energy can feel like magic, or maybe just, super confusing. So how do we close that gap? That's the puzzle we're going to try to solve together.
So, our story really begins here, in this world of the unseen. We're surrounded, literally all the time, by these massive ideas that explain how our universe works, but we can't just point to them. Things like,
Okay, first up, matter. We're told our whole lives that everything, the very chair you're sitting in, the air you're breathing right now, it's all made of these teeny tiny particles that are impossible to see. It's one of the most basic ideas in science, but for a kid, it's completely abstract.
And then you've got forces. We feel their effects constantly, right? Like gravity, keeping us glued to the planet. But the force itself, you can't see it. It's just this invisible push or pull that runs the whole show.
and of course, there's energy. We see what it does everywhere we look. Sunlight warming things up, electricity making things go. But the actual flow of that energy from one thing to another, yep, another incredibly powerful, invisible process that shapes our entire world.
So with all these invisible giants running around, how do we make sense of them? Well, what if we stop thinking about it like a lecture and start framing it like a quest? You know, a story that's all about investigation, where curiosity is basically your map.
And the amazing part is that this whole big quest starts with something incredibly small. It starts with just noticing something in the world around you, and then asking that amazing, powerful question. Why'd that happen? That's where the real magic begins. This brings us to the really fun part, the idea of solving these mysteries with a hands-on approach. This is the moment when those fuzzy, abstract questions turn into real, solid discoveries. Let's take a look at how that actually works.
So let's meet Maria. She's just going about her day, opens the window, a breeze comes in, and whoosh, her papers go flying. Now, most of us might not even think twice about it, but for a curious mind, this is an event. It's an observation that sparks a question. And here it is, the question. How does that happen? What is this invisible stuff that can actually move things from one side of the room to the other? All of a sudden, a little gust of wind isn't just wind anymore. It's a scientific mystery.
And just like that, we have a perfect way into the concept of matter. See, the exploration isn't about looking at a diagram of an atom. No way. It's about investigating the proof, the moving papers, to understand that air, even though we can't see it, is made of real, physical stuff that takes up space and can push things around.
Okay, now let's check in with Daniel. He's outside looking at nature, and he sees something that honestly looks like a magic trick. These little birds just perched on a branch that's swaying in the wind, and they are perfectly, effortlessly balanced. It's incredible.
So of course, his observation sparks that next question. How are they doing that? What is the invisible secret that lets them stay so perfectly stable, even when everything around them is moving?
And the answer connects directly to the concept of gravity. But here's the brilliant part. The exploration isn't reading a chapter in a textbook. It's Daniel building his own model bird. By physically trying to get it to balance, he starts to get this deep, intuitive feel for the center of gravity. He can literally feel that invisible force at work. It's amazing.
Now here's a totally different kind of challenge. This one's from Sophie. It's a practical problem, more of an engineering puzzle. She needs light to be safe at her campsite, but she wants it to be a smart light. So this leads to a really cool design question. How can she build a lamp that's clever enough to turn itself on only when it gets dark? This isn't just about watching the world. This is about trying to create a solution for it.
Now, what I think is so cool here is how this one little engineering problem cracks open a much bigger scientific idea, the patterns of daytime and nighttime. This little lamp project could lead to a whole investigation into Earth and space science, like why the amount of daylight changes through the year, all because she wanted to build a smart lamp.
All right, our last example brings the whole gang together. They start with a piece of information they already have. They know that plants use the sun's light to get bigger and grow. That's a great starting point.
But that knowledge leads them to a much deeper, more complex question. Okay, so plants get their energy right from the sun. But what about animals? We don't exactly sunbathe for lunch. The connection is way less obvious, and that makes it a perfect mystery to solve.
And this is the perfect setup to explore energy transfer, or what we usually call food chains. The exploration here is to build a model that actually lets you see how that energy moves. You can trace it from the sun to the plant, then to the animal that eats the plant, and so on. It makes that invisible flow of energy through an entire ecosystem something you can actually see and touch.
But here's the thing, and it might be the most powerful part of this whole idea. It's not just about teaching science. While these students are building all these cool models, they're also building something else, something internal. They're building the tools they're going to need for all of tomorrow's challenges.
Just think about it. When Daniel's model bird keeps falling over and he keeps trying, he's learning persistence. When the whole group has to work together to figure out that food chain model, they're building empathy. This whole process forces them to practice self-regulation and mindfulness. These aren't just words on a poster. They're skills being forged while solving these fun, hands-on problems.
So what's the big takeaway from all this? Well, it's about so much more than just science facts. It's about learning to see the world differently. It's about giving kids the tools to understand the unseen forces and the invisible structures that shape every single part of their reality.
And that leaves us with a pretty powerful thought to end on. If an approach like this can teach a child to truly understand an invisible force like gravity, then what else does it prepare them for? What other invisible barriers, social challenges, complex problems, maybe even their own personal struggles can they learn to see, to understand, and ultimately to overcome? The potential there is just huge.